So my name is Colin Train. I'm Vice President of Delivery Services for Nexus. Go ahead.
No, please.
Is this-
Okay, we are improvising because we don't have the slides. We are trying to see. Okay, no problem. So, please, Colin, introduce yourself and then.
I did. Go ahead. After you.
Okay, so my name is Federico Levin. I'm the big data architect for Nexus. And well, in this presentation, we are going to talk about Flume for telco operators. And also we are going to cover an end-to-end architecture, from the external sources to the final user reports. Regarding Apache Flume, we are not going to talk in very detail about, let's say, how to customize, how to implement or talk, because there are very few books and good reference about that. But we're going to show you how you can use it and why we use Flume when we use in IT telco infrastructure. So, okay, now at this point, I need the...
Okay, so Nexus, I'll give you a little background about Nexus really quick. So Nexus specializes in deploying network services for large network providers as well as corporate organizations. Okay, we do this in varying ways. We have a construction arm of the company that can actually install the fiber, can install the cell towers. We have the telecom network specialists, the engineering side of the house. They identify emerging technologies. They can communicate that and educate the providers. And we have a software side of the house as well as solutions. And the software side is where we're specifying today, where we're talking about big data and how we can leverage the power of Hadoop with Flume to provide a coalescing or correlation of all this data that's out there. And just to provide some grounding background as to what happens in this telecommunications network space. Think about a graph theory, right, back to nodes and edges. So out in the telecommunications world, that network is extremely complex. But the idea is very simple. You still want to get information or data from point A to point B. And in order to do so, they have to transfer that electronically across their network. And at each one of those nodes or those hops, right, they're capturing data in log files at the network devices. And all that data is kind of all just sitting there waiting to be leveraged and used. This data identifies things from our cell phones that you carry around, right? What your locale is, all kinds of data that they're not ever able to leverage today to the fullest extent that they can. So what we'll demonstrate when we get the slides is how we can put Flume in there from a pub sub model, plug that into Hadoop, and pull all this disparate data, okay? All this data from across all the nodes that they use to operate their network, from social data, from spatial data to graphical, topology data, and understand where people are, how they're leveraging the network. It will answer questions like churn. Like all these CSPs, these communication service providers, they have churn in their network. They have churn with their users or the customer base moving from one, say like your telephone company or your cell phone company, you're moving from one cell phone provider to another to another. So there's churn. They're trying to understand why, right? Where are their high-risk customers? What are their valuable customers? Why would they want to move? So what we're going to propose is an opportunity for them to look at this data and understand better, not just the streaming data of how their network is performing and how it's either not optimized or how it is performing, what have you, but also how they can leverage this data to identify customers who are about ready to jump or at high risk of leaving, okay? In addition, right, they might also want to ask questions around what other services can I provide for my customers? There'll be slides to go with all this. What kind of services can I provide that I haven't already provided? What are the services that are being used the most? What other opportunities? There you go.
Okay, great.
Can you skip forward to the?
Okay, so.
Yeah, that's about us. And below. Okay.
Okay, good.
So just again about us. So prior to joining Nexus, I worked for Level 2 Communications for 15 years. I was a software developer. I held many occupational roles, including software developer, enterprise architect, and even senior director. I'm now VP of Delivery Services at Nexus.
Okay, just a few lines about me. I'm from Argentina, and I suppose most of you no Argentina because of Messi, and that will be, later we can talk about Messi. That will be another a nice topic to talk about. And also, as I said, I'm the big data architect at Nexus, and my main role is to integrate Hadoop in the enterprise, because I think one of the, I'm going to say the main problem, one of the issues that is on the enterprise, the adoption of Hadoop, is how to integrate them with their current infrastructure. Because you cannot just go and drop whatever you have, the data warehouse, the traditional data warehouse, and all the processes, and just drop everything and implement Hadoop. So I work on how you can, let's say, integrate the traditional data warehouse with the Hadoop platform, okay, to have a better platform, a more powerful platform for data analytics. Okay, so here we can see what is the traditional data sources that a telco operator needs to collect. We have, starting from the left to the right, we have the POC and the and the customer care information. Then we have the billing system, okay, that is all the data that's being generated for billing purposes. And also then we have the data that is generated and collected that is coming from the network, okay? All that data that is called CDR data, okay, that I've been talk about in the next slide. All these data sources are the telco operator is collecting, at least at this moment. Then we are talking about the new data sources that needs to collect for an enhanced data analytics platform, okay? But so these are all the types that are currently collecting. So let's talk a little bit about CDR data. CDR stands for call detail record. Call detail record are all the records, and let's talk about a little bit for every operation that you do, every call that you do with your cell phone, every text message that you send, every multimedia message, also any data that you send when you're doing a communication with your cell phone is generating a CDR record that generates the devices in the network, generates and store a record, as part of the CDR. And also we have other types that are the data proofs, okay, that are called the DPI, and we have also the KPI data. The DPI stands for packet inspection, and allows the telco operator to analyze all the traffic, all the activity in the data packets that a user is transporting or generating or doing in the network. For example, when you are using your application in your cell phone, your smartphone, you're generating data packets, okay, you are generating traffic over the internet, and that can be traced using this DPI, the packet inspection data. And then we have the KPI. The KPI stands for Key Performance Indicator. The Key Performance Indicator in the telco operator allows to analyze what is happening in the network at that moment. For example, if there's a congestion in the network, what is the activity, what is happening in a specific area, okay? And that allows to know what is happening at any time on the network for a telco operator. Plus this CDR data types, okay, that are the one that the telco were collecting, no matter that due to the size of the data, because you can imagine that all the CDR data is being generated in the network at any time. The size is so big, the variety also is so complex, because the voice CDR are in a different format than the SMS CDR, than the multimedia CDS, than the data CDR format. So you have a big volume that you are generating from the network, a real different variety of formats, okay? And also the speed that's being generated. So by now the classic approach by the telco was to discard most of the data and just using for billing purposes the data that they need to use it to generate the billing for the subscribers, and maybe getting few small samples, okay, from the KPI and the DPI to do a sampling over the network and have an idea what is happening. Or maybe if they know there is a problem in a specific area, start to collecting all the data for that area. But they are not able to collect and manage all the DPIs and KPIs and also all the CDRs with all the columns available that they are generating. Plus all these data sets, we have the new data sets that are coming from what we can call the Internet 2.0 or Internet of Things era. There are the social media data. We have also the weblogs or any data that are being generated by the weblogs or websites, okay, that the user is browsing. And also, we have data that's being generated by GPS or geolocated devices in the network. Means users, means devices, okay? All the devices that transmit packets can be geolocated, okay? So we have, plus the traditional, we have all these new data sources available to collect and to analyze. Okay, so here we can see, okay, what is implementing or what type of data warehouse infrastructure is running a telco operator at this moment. Is running the classic enterprise data warehouse where you have all the data sources. We have a set of collection servers, okay, where you go to, or the different data sources are storing the data, okay, because usually the telco operators are not giving direct access to the devices in the network or to the internal systems, okay. So what it's doing is downloading data to intermediate collection servers, and from there the ETL servers are downloading the data, transforming everything, and storing the data in the enterprise data warehouse. And usually you have a very big data warehouse because there's no, you need to, let's say, load the data in the data warehouse, transform everything, and make it available for the final user report. So you are running a very big data warehouse to analyze all this data and collect them. So what would be the Hadoop approach to this problem? How we can improve, how we can have a more powerful, how we can be able to collect and to analyze all these data sources, but by now, or we are not collecting because there are new data sources from this Internet of Things times, or we are not able to collect everything because we need to discard, we are not able to store this amount of data in a traditional data warehouse. And that's when the Flume component comes into play. So we can see that we have the different data sources, and the Flume component is able to connect directly to them. Connect directly to them, collect the data from there, okay, and then move it without any ETL or any transformation needed in the middle into Hadoop, okay. So what we have, compared with the previous one, okay, and just going back quickly, going to the previous one, we have in the previous we need to collect and transform a very big data size and also a very big variety of data sets. And now in this new architecture using Hadoop, we are able just to collect and store directly in Hadoop and later have it stored for later analysis and using Hadoop as the analytic platform, okay? So, and we are still keeping on the traditional data warehouse or the relational databases data warehouse. We are not using Hadoop directly. We can have it and use the data warehouse to support the user report, having the advantage of the relational database for the SQL, rich SQL language, and also the fast online SQL access. Compare, and I don't want to get here in the discussion in terms that if Hadoop is able to provide a certain performance as a relational as an enterprise data warehouse running on a relational database, but the point is, in the experience, we can see that business intelligence system and reports run better. Also, the user experience is better when you are running the reports on top of an enterprise data warehouse on a relational database. Okay, so let's talk a little bit about Flume. Okay. Okay, so what is Flume? Flume is a service that streams events and is distributed, reliable, easy to use, flexible, and extensible. So let's talk a little bit about each of them. Why is distributed? Distributed because you can have running multiple instances of Flume in different machines, okay, or in the same machine, but you can have multiple instances. So you can have a distributed architecture running on for the Flumations. It's reliable because with the proper configuration, you can be sure that you're not going to suffer any data loss in case of one of the Flumation fails. But now we will see later how we need to configure to, let's say, have this reliability on the data transportation. Easy to use because it's very simple to configure a Flume agent, okay, and have it up and running, okay, just setting a set of configuration in the configuration file. Then it's flexible because it can be easily adapted to multiple use cases, and now we are going to see the use cases that we have to adapt for the telco domain. And it's extensible because you can easily, using Java, you can create your custom Flume behavior and objects inside the Flume agent. So what is the usage? The usage for the Flumation is to move and collect data from external sources into, and are mainly designed for Hadoop, but it can be any other storage, okay? For example, you can have local file system, or even you can develop your custom storage where you want to store the data. But Flume was mainly designed to store data in Hadoop. Of course, HDFS, HBase, and also there's a Hive storage that is available, but no more is under development. Now maybe you're saying, okay, Flume is great, but I know the Kafka is also available, and I know there's a lot of implementation running Kafka. And yeah, it's true, but just to make let's say the main difference between them, in my opinion, is that Kafka is more generic, so you can adapt it to more use cases, okay, or it's easier to adapt to multiple use cases, but that flexibility comes up with a price to more complex to implement. But again, that could be we know there's if there's some Kafka expert here, could be a discussion in terms of is Kafka is easier or not, if it's let's say to implement or more flexible or not. But the point is that if you under my experience, I have to say that it's more generic but more complex to implement. Okay, so first let's go to a few key definitions about Flume, okay? We have three things that are the client, the event, and the agent itself, okay? So the client in the Flume terminology is the initial point where the events are generated, okay? And what is an event? Event is the data unit transport by Flume. So when you're talking about what is, let's say, what is moving Flume? Move in the terminology is moving events. It's not moving data, okay? No matter that, of course, I'm moving data because that's what that I want to send to Hadoop. But the point is that you will find that the right term is event, because you're streaming events through Flume to the final storage. So what is an event? It's the data unit, and it's a set of headers plus the data that I'm transporting using the Flume agent, okay? It's just like that. And what is the Flumation itself? A Flumation itself is a Java virtual machine process, okay, that can be run independently in any host, just installing the proper libraries and having the Java virtual environment enabled on the host. So it's not dependent on the Hadoop environment itself. Let's say it's independent from Hadoop, if you want to say that. No matter that, if you want to store the final data in HDFS, you have to reach, the Hadoop platform, but can be run in a separate machine. And later we will see how we can, let's say, from an isolated machine from Hadoop, we can store data inside Hadoop. So the Flumation is, at the end, is a component that is compound of a source that connects to the external data, a channel, okay, that is like a buffering area where the source is pulling events inside the channel, and then, it's pushing events into the channel, and then we have the source. The source is the one that is in charge to store the events in the final storage, and is pulling these events from the channel to the source and then to the final storage. So the channel will be the buffering area between the source and the sink, and is able to, let's say, stabilize different speeds between the source that is reading events and the sink that is storing events in the Flume agent. So here we can see down, what is the basic architecture. Now we have a source, and the events are being transported over the source, the channel, and finally the sink. Okay, so let's go quickly over the agent configurations. Okay, we can configure a Flumation, and we can configure the source and decide where is going or from where it's going to read the events, we can configure the channel and say, okay, where you're going to buffer this data, and you can configure the sink and decide where you're going to store your data. And then we have the interceptor that I'm going to explain a little bit. That gives you the ability to capture events between the source and the channel and modify them, or you can even decide what to do with the event. You can discard them, you can transform them, or even you can decide and say, okay, I'm going to send it to a specific channel, and then we will see how you can configure more than one channel and more than one sink for each source that you have. So in the case of the telecommunication domain, for the source, usually the most used source is the spooling directory. Spooling directory gives you the ability to read files that are being stored inside a folder in a specific server. So what is going to do the Flumation is going to be spooling that directory, that folder, and each time a new file is coming, it's going to read the entire content and is going to stream the content through the Flumation, and it's going to rename the file to make sure that that file was already sent using the Flumation. So it's not going to repeat the same file, okay, in case that is already processed. Then, of course, then we have other, for example, the exec is other type of source that allows you to execute a Linux command. For example, usually we use it to execute a tail command over a log file, okay? And you're getting, for example, the last 100 lines, okay? So we are sure that you are getting, you know, the last data that's been stored in that log file. And then we have other, the Avro is another important that we will see that gives you the ability to chain multiple Flumations, okay? Then we have the HTTP, and in every case you can see that you can customize the source, you can customize the interceptor, the channel, and the sink. And that's one of the main advantages. Let's say it's easy to extend, and also gives you the ability to extend all of the components inside the Flumation. Okay, let's go to the channel now. Later we will see the interceptor. We have the channel. We have the main two type of channel properties. We can use the memory channel. The memory channel is storing the events in memory. So it's the faster, it's the fastest channel to use because it's storing the events in memory. But the problem is it's not reliable. It's not reliable because if something happens with the Flumation, you're going to lose all the data stored in the channel, okay? Because the process stops and all the data in the Shabba virtual machine will be lost. So usually what you need to use to provide reliability, you need to use the JDBC or the file. The JDBC allows you to connect to the database and store the events in the channel inside the database. And so the events will be coming from the source, will be stored in the database, and then the source will be pulling the events from the channel by reading the database. But that is, I have to say, that this is a small channel type. And then we have the file that is the most usually, okay, or by us in the telco domain, that store events in the local file system where the Flumation is running. And in that case, you have a reliable channel, because if the Flumation stops and then you relaunch the Flumation, the events will be resumed, let's say, will be recovered and can be resent to the sink. And also it's faster compared with the JDBC channel. Then we have the sink, and I'm going to talk about HDFS, HBase are the most used to store data in Hadoop. And then we have the interceptor. The interceptor is this, let's say, component that can or gives you the ability to capture events after you know the source and decide what to do. You can modify them, okay, and send it to the channel. You can discard them if for any reason you don't need that event, or you can decide if you're going to send to a specific channel and you're going to send this later. Okay, so here we can have what we can call a distributed Flume architecture. We have two Flumation running in parallel in the same host. And I wanted to show that you can have running multiple Flumation in the same host, because you don't need to have one Flumation per server or per host. And in some configuration, and maybe sometimes is not that you will see, but you can have multiple Flumations. So you don't need, let's say, if you need 10 Flumations running, maybe you can accommodate them in 3 servers, okay, or in 3 machines. Now there's another problem. You may say, okay, and what is the sizing? What is the size that I need to estimate for my machine? What is the sizing that I need to estimate for, depending on the streaming that I'm going to manage over my Flumation? Well, I have to say, and that's, let's say, another topic that is complex to discuss, but the Flumation are mainly affected by the number of events that the source is consuming and storing in the channel. So when you're, of course, there are then a set of different techniques where you can calculate or you can estimate what will be the RAM that you need and the CPU that you need in the server running the Flumation. But the first variable that you need to take into account is the number of events that you're going to manage through your Flumation. And in this case, again, we have a distributed, and we have that one is stored in HDFS and other is stored in HBase. One is reading from a network folder share, okay, that could be using the spoiling directory, and the other is from a HTTP API. For example, consuming from the Twitter API, okay, could be consuming from a HTTP API. Now we have another architecture that is important, you know, as part of the Flume component itself, but also for the telco domain, is what is called the multiplexing replicating. Multiplexing replicating gives you the ability to use more than one channel for each source. It's not only limited to two. In this case, I'm just for space, I'm using 2 channels, but I can have more than 2 channels connected to a single source. And then when I have more than one channel, I have to decide how I'm going to use all those channels. I can use multiplexing or replicating. Replicating means that I'm going to send the event that is being sent out from the source to all the channels in the Flumation. So what will going to give me using a replication will give me that the event will be stored in all the sinks that I have configured in my Flumation, and that will give me the ability of, let's say, high availability of the data and no data loss. So let's say that I have 2. In this case, I have HDFS as one of the sinks and the local file system for the other of the sinks. Let's say that for some reason my Hadoop cluster is not reachable. So what will happen? Do I going to lose all my events? No, I will have a replication, you know, configured, and I'm going to store, you know, the same events to the local file system, while I can fix the Hadoop or see what is the problem, and then I can recover all those events stored in the file system and store them in Hadoop. Or I can use multiplexing. Multiplexing gives you the ability to decide what will be the channel that you're going to use to send the event. So you can decide based on some information, some data inside the event, or any other criteria that you want to use. So after the event is leaving the source, you can decide, okay, what I'm going to do with this data. I'm going to send it to this channel or to this other channel. And how we usually use this multiplexing in the telco domain. We use it for partitioning data first, or we use it also to separate safe data from data that has error, or we don't need to mix it because they have some type of or didn't pass some data validation that we are doing. So partitioning means that, for example, we are collecting data, okay, and we need to send, let's say that we have data that is being mixed by year, but we want to store them in different HDFS folders, okay? So you can have multiple channels, okay, and decide, okay, if this record is coming from a specific, or belongs to a specific year, I'm going to send it to one channel and store it in HDFS inside a specific folder. And if it's coming from another year, I can send it to a different HDFS folder. So that's the purpose of multiplexing. It gives you the ability to decide and partition your data, okay, based on some criteria. Also divide safe data with errors. Another important architecture, and also that we use in the in the telco infrastructure, is what we call consolidation. Consolidation has 2, let's say, characteristics. First, gives you the chance to, having multiple or different sources, you can consolidate all this in a single HDFS storage. But also gives you the chance to Also, and give you the chance to, if you need to, for some reason you have data that's mixed in different collection servers. Let's say that you are collecting the same CDR type, okay? For example, you are collecting voice, okay? But you have the data from, different devices in the network. But you want to have store everything in the same HDFS folder, because no more that the data is coming from different, devices, but I want to have everything consolidated in a single storage. So I'm going to use the consolidation architecture in Flume. But also, we can see here that we are chaining two Flumation, okay, to reach HDFS. So what does it mean? That I can have a Flumation running on an isolated machine that is not reachable, or I cannot reach HDFS from that machine. But what can I do? I can chain my Flumation, okay, using this consolidation, but no more in this case cannot be maybe a consolidation because I'm just chaining multiple agents, okay? But I can reach from a machine that is outside or is running a specific device. I can start, moving the data and transporting the data through different Flumation till I reach, the final storage that I want to use. And that's a classic usage in the telecommunications, because usually we have the Flumation running in a collection server, okay, that is outside even the Hadoop LAN that where it's running. So I can go from that collection server, connect to another Flumation, and that Flumation maybe will be connecting to a third, Flumation that is running inside the same network of the Hadoop cluster, and then from there I'm going to store my event inside HDFS. Okay, now I'm going to talk a little bit about extensibility. And now we can see how easy it is to customize or extend your Flumation using Java. You can extend your sources, your sinks, and your interceptor just implementing 4 methods. Even if you don't need to, for example, implement something very complex. Just implementing, for example, for the case of the source, just implementing the process method, you will be able to manage your event as you need. Okay, what does it mean? That you can get the events from the source and decide what to do and how you're going to manage them and how you're going to send them to a channel, but customize, not using the built-in functionality from the Flumation. The same for the sync. You can decide if you want to use a different storage than the HDFS or HBase, you can customize your sync and decide, okay, I want to, for example, not even store in the local file system, but maybe I want to send it to an HTTP API. Let's say that I want to store or send my events to a API outside the Flumation. I can customize my sync, and I say, okay, when I got an event, I'm going to send it to an API. Okay, so I don't need to use event, or I can extend to go beyond, local file system and HDFS. And then we have also, I can customize my interceptor and say, okay, I'm not going to use the different interceptors that I have available, let's say using regular expression or the built-in interceptor. I want to use a specific interceptor to do some type of ETL. Usually you extend your interceptor to do ETL transformation of your events. So you get the events and you transform inside the interceptor and you decide where you're going to send them. Sorry? Here, if you can extend the channel. Yeah, you can extend the channel, but the problem is that when you're running the Flumation in a local server, in your server, you don't have much choices than memory or a local file system. But you can extend, or you can, let's say, customize your channel to decide where you're going to buffer your events. I didn't show the channel because, let's say, I don't have any example in the in our experience to customize a channel, but you can customize if you need it for some reason. But if you think at first, what other choices than memory or file system to buffer your events? But that's okay. You have the ability to extend them or customize. Okay, now I'm going to go briefly to this end-to-end architecture. This is based on our platform, okay? So we have the external sources, okay? Social media that we said that are the, our new data sources. We have the internal system like CRM, billing, ERP, and we have the CDR data. So using Flumation, we are collecting, using a separate set of Flumation, we are collecting this data. And by now we are running a batch method process, our current platform is running on the batch mode. So we are storing everything in HDFS and using tests on top of Yarn, you are processing this data. And we are running a set of machine learning classifier. Okay, so we are able to, using the social media, we are able to identify the topic that the user in the social media is talking about. We are able to score the sentiment, okay? And also we are able, or we try to match the subscribers that we have in the billing system to the user in the social media. So we are able to know what our subscribers are saying, in the social media networks. What are the feedback about our company? Then after all this enrichment and process, we export this data to the data warehouse that will be supporting the final user reports. Okay, here we have a real example of Flume configuration, and I want just to make focus on the third block when I'm configuring the multiplexing. If you look in the third block, I'm saying, okay, I'm going first. You can see in the third line, if I'm not wrong, sorry. Yes, in the second line, sorry, you will see that I'm configuring more than one channel for my Flumation, okay? So what does it mean? That, or I need to do a replication or a multiplexing. In this case, we are using multiplexing, and we use multiplexing based on a field inside the events that is called message type, okay? And based on the content of this message type, that could be normal or that could be error. If the message type is normal, because the data is correct, is safe data, we are sending to a specific HDFS folder, partition by date, a month, and year. But if the data is coming with an error message type, because we analyzed the data inside and we saw that, for example, it's not passing the validation, it's coming with null values inside the columns, we are sending to a different channel. So let's say configuring the multiplexing is just simple like that. Just saying, okay, I'm going to use more than one channel, and how I'm going to use and how I'm going to decide where will be the channel, what will be the channel that I'm going to use. So, okay, we have a set of user reports, okay, that are based on the data that we are collecting. We are collecting social media data, we are collecting internal system data, and we are collecting CDR data that are answering the questions that Colin was mentioning, previously about how can I satisfy my customer better? How can I avoid them to churn from my company? How can I improve my usage network? So, Colin, I would like if you. Okay, please. Okay, good. So, okay, so for example, in this case, if you see the the stock bars in the bottom of the chart, gives you information about what the customer are saying based on a set of topics. For example, what the customer is saying for our voice service, what the customer is saying for our data service. So we are saying, for example, for the voice service, 10% are saying the services, or they have a bad sentiment about our voice service. Then we have a 30% that have a neutral, sentiment about our voice service, and then we have a 40% that have a good feedback. The same for the data service, the same for the customer care, or for example the call center for the customer, attention. Then also we can use, and here we can see how we can geolocate the devices and what the people are saying geolocated in the area in the map. So we can say, okay, in this area we are having good feedback, okay, from our customer, but also we can match with the data that we are collecting from the network. So we can say, okay, what we see from the network and what we see from the customer, and compare them. Maybe we have a bad feedback and our metrics for the network are good. So we decide to say, maybe, okay, we have a discrepancy we need to analyze. Or maybe no, we have a bad network performance, and at the same time we have a bad feedback from the customers. Okay, so now briefly and finalizing, this is our next generation architecture. We are moving from batch to real time. We are replacing Hive on test and Yarn on test with Spark on Yarn. And instead of using machine learning API libraries, we are using the machine learning libraries from Spark. We are in the middle of the process, so we are moving to a near real-time platform to analyze this data. So, well, just finishing, I think these are 4 books that are important for anyone who, wants to know about Hadoop and Flume, how to implement, a full stack, application using Hadoop. And well, thank you, and sorry for the inconvenience at the beginning. And if you have any questions or Samson, please.
We'll make
Yes.
ourselves available outside as well after this. Sorry for that.
Yeah. Sorry, please could you repeat? Source, channel, and sync. Yeah. Is by transaction. Later I can explain you. Is processed by transactions. Okay. A set of events are processed and saved by the transaction. It's not one event by one. But later we can. Okay.
Hi. I was wondering how many messages you process per day, per hour, and how do you estimate your data loss? Because, for example, the node just crashed before being able to push to the next, that you are in memory and you crash in between.
Sorry, no, please repeat me. Sorry.
Okay, sure. So how many messages you process with Flume, like
Yes.
every day? And because of the crash, like, what's your data loss? Or do you have a good idea of your data loss, if any?
Well, are you saying about estimating the sizing or estimating the flow in the Flume?
He's talking about what happens if there's a crash.
Yeah.
And
No.
how much data you're going to lose. Well, so
No.
the channel is durable, right, if you persist that to a data store, like he was describing earlier.
But if you use, for example, the memory channel for
If
Use
you're
memory,
If you're using the memory channel, you're going to lose all the events that you have in the channel. That depends on the size of the transaction that you define. You can define your transaction by a number of events, from 1 to whatever. Each transaction will be moved from the source to the channel. So if you define a very big transaction, and at the end will be a very big number of events, you're going to lose all that you have there, okay? But let's say once the for example, the sync start reading the events from the channel, will read it as a transaction. So once it started, okay, you are sure that the sync will take care and read all. But while they stay in the channel, if you have a crash on the Flumation, you're going to lose them. That's why you need to use file if you need reliability on the.
Yeah, but if you lost the node, you lost the files too, right? Possibly.
Yeah, but also you have a performance problem using the
so
file.
that's why I was wondering, like, how many messages and, like, depending how you can estimate or what's the tuning can do to minimize the loss of data. Like
okay, so minimize it, right? 2 channels.
Yeah.
Replicate across. One is for memory and optimal performance, right? The other one's durable. So you're getting the messages across, and that's how you handle that.
Okay. And just how many messages? I mean, for the telco, I mean, what's usually an order of magnitude of how many messages you process with Flume? Just like hundreds, thousands, billions? I mean,
You're saying that the
like in the
How
beginning
large?
of the talk, yeah.
the number of yeah, well, that depends on let's say on the source that you are consuming. But for example, you can manage millions of events,
More.
per, I don't know, depending on how you configure and how is the rate of the events being generated in the source. But you can size, let's say the limitation that you have is the hardware, and the have a virtual machine limitation. So if you're able to size properly the Java virtual machine and the hardware, you can accommodate all the events that you can. You have, let's say, no limitations. The Flumation has no intrinsic limitations in the number of events that can manage, if that answers your question.
Not
Ma-
really, but
no,
it's fine.
no. Okay,
we can
we
discuss
can
later.
talk. Okay,
Sure.
sure.
I have a question.
Okay, thank you. Bye.
Excuse me, I have a question.
Yeah,
So
sure.
will it work for batch process or only for real time?
Sorry.
The Flume work for batch process or it's only for real
No,
time?
the Flume can work for batch and for real time. Let's say you can connect Flume to a batch, engine, like for example MapReduce, or you can connect Flume to Spark. Okay,
Mhm.
so you can, let's say, stream events via Flume and send it to Spark. So let's say Flume is not tied to batch or real time. Okay, no matter that it's able to handle real-time engine like a Spark or a Storm, for example. Okay.
Yeah, I have a use case like to transfer unstructured data from one of the server to HDFS. So I'm just looking to use for that.
Okay. Yes. I don't know. Outside, if you want to.
We can make ourselves available to answer questions.
Yeah.
Okay.
Yeah, we'll be right outside. So.
Okay. Thank you.
Yeah. I don't want to overlap the next presentation.
Thank you.